Hello, grade 9 students. Okay, we are now through discussing the different types of variation, like the direct variation, inverse variation, joint variation, and combined variation. So we will now proceed to the next, that is to apply our knowledge with those different kinds of, the different types of variation. Let us now learn how to solve problems that involves variation. So the MELP for this topic solves problems involving variation. I have here the learning objectives. Recall the concepts of variation. Express a variation statement as an equation of variation and vice versa. And number 3, follow the steps in solving problems involving variation. And number 4, solve problems involving variation. Let us first have a recall on the different types of variation. Okay, so let's start with direct. So there is a direct variation whenever a situation produces pairs of numbers in which the ratio is constant. The statements y varies directly as x, or y is directly proportional to x, or simply y is proportional to x. And this can be translated mathematically as y equals kx, where k is the constant of variation. So ito yung equation of variation ng direct variation. Y equals kx. So for two quantities, x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. Okay, you have already learned that from our previous lesson on variations. So pag inverse variation naman, it occurs whenever a situation produces pair of numbers whose product is constant. And for two quantities, x and y, an increase in x causes a decrease in y, or vice versa. If x increases, y decreases, or vice versa. So we can say that y varies inversely as x, or y is equal to k over x. Okay, so for joint variation, it's just like direct variation, only it involves a third or fourth variable. So the statement A varies jointly as B and C. This means as A equals K times B times C, where K is constant of variation. B and C means product, not addition. Okay, so that's the caution for joint variation. And then pag combined, it's just a combination of direct, inverse, or even joint variation. So the statement T varies directly as x, inversely as y means T equals kx over y, where k is the constant of variation. Now let us learn how to translate variation statements into mathematical equations and vice versa. Take note of the terms used such as varies directly as, is directly proportional to, varies inversely as, or varies jointly as. So pag if x is proportional to y, that means this is direct variation, so x equals ky. R varies inversely as s, r equals k over s. This will be our mathematical equation. Z varies jointly as x and y, z equals kxy. T varies directly as u and inversely as v, t equals k over v. Distance d is directly proportional to time t, d equals kt. A varies inversely as the square of b, a equals k over b squared. W varies jointly as x, y, and z, w is equals k, x, y, z. Mass m of an object varies inversely as the acceleration due to gravity g, m is equal to k over g. P varies directly as the square of x inversely as s, p equals kx squared over s. B varies jointly as c, and the square of a inversely as b. W is equal to kca squared all over b. I think you already know how to translate variation statements to mathematical equations. Just remember the equation of variation, the variation equation for each type. So pag direct, x equals ky or y equals kx. Pag inverse, y equals k over x. Now let us go to the steps in solving problems involving variations. Letter A, identify the two sets of given values. Express the variation statement as a mathematical equation. Solve for the constant of variation k by substituting the first set of given values in the equation. Form the equation of variation by substituting the variation constant k in the mathematical equation. Solve for the unknown by substituting the second set of given values in the equation of variation. Okay, we have here now a word problem involving variation. The amount of paint P needed to paint the walls of a room varies directly as the area A of the wall. If 8 liters of paint is needed to paint the 4 square meter wall, how many liters of paint are needed to paint a wall with an area of 100 square meters? Okay, so it says here that the amount of paint P varies directly as the area of the wall. So our equation here is P equals Ka, right? Because there is a direct variation here that involves, yes, P equals K over A, right? So first identify the set of given values. So for the first set, P equals 8 liters of paint, area 4 square meter more 4 square meter wall. Now for the second set with unknown, let P, how many liters of paint are needed to paint the wall, it says here. So P is unknown and the area is 100 square meters. So dito na yung sinasabi ko, amount of paint varies directly as the area A. So our equation here is P equals Ka, or mathematical equation P is equal to Ka kasi direct variation, no? Then let us now solve for K by substituting P with 8 area by 4. So 8 is equal to P equals Ka, 8 equals K times 4, divide both sides by 4, cancel 4, K equals, K is equal to 2, right? Or simply, when we are dealing with the constant of variation, when we have this equation P equals Ka, we just divide P by A. What is P? 8. What is A? 4. 8 divided by 4, 2. So the constant of variation is 2. We will now substitute this in the original equation P equals Ka. P equals 2A na. Magiging P equals 2A na. Yun. This will be our equation of variation now. P is equal to 2A. And from this, we can now be able to solve for the unknown. The unknown is P. Okay. How many liters are needed to paint a 100 square meters wall? So P equals 2A, 2 times 100, 200. So we need 200 liters of paint in order to paint a 100 square meter wall. Okay, that is how we solve problem number 1. Yes, so 200 liters of paint are needed to paint a wall with an area of 100 square meters. Okay, another problem. The number of days needed in repairing a house varies inversely as the number of men working. It takes 15 days for 2 men to repair the house. How many men are needed to complete the job in 6 days? So this is an example of an inverse variation problem. Okay. So if there are 2 men only working to repair the house, it takes them 15 days. Now, how many men should be working so that they complete the job in 6 days? Okay. So this is an inverse variation problem. So our equation will be, first identify the first 2 set of given values. For first set, the number of days is 15 days. The number of men is 2 m. For the second set, 6 days. How many unknown number of men? This will be our problem here. What is the number of men needed to paint the job? Repair the house in 6 days. Yes. So since this is an inverse variation, D is equal to K over M will be our equation. Yun. D is equal to K over M. Then let us now solve for K. Substitute D by 15, M by 2. And solve for K, just multiply D by M. 15 times 2 is 30. That's a shortcut. D times M, or 15 times 2 is 30. This is now the equation of variation, and then we will substitute K by 30 here in the equation. D equals 30 over M will be our equation of variation, and from this equation we can now solve for the unknown. The unknown is yung M. How many men needed to repair the house in 6 days? Substitute D by 6. 6 equals 30 over M. So to solve for M, we just divide 30 by 6, which is 5. So we need 5 men. Okay, we need 5 men to complete the job in 6 days. So, right, that is how to solve problem number 2. It's an inverse variation problem. How about this? This is a joint variation problem. The weight of a rectangular sheet of wood Z varies jointly as the length of X. As the length X and the width Y. Now, when the length is 3 meters and the width is 2 meters, the weight is 180 grams. Find the weight when the length is 5 meters and the width is 3 meters. Identify the two sets of given values per set. Okay, X, length of the wood, 3 meters. Y, here. Width of the wood, 2 meters. Z, weight of the wood, 180 grams. For the second set, X, length of the wood, 5 meters. Y, width of the wood, 3 meters. Z, what will be the weight of the wood? Z. Okay. Ito yung hanapin natin. So, solve natin. This will be the variable that we are trying to find out. So, since this is a joint variation, our equation will be Z equals K XY. Z equals K XY. Yun. Then, let us now solve for K. Substitute Z by 180. Okay, from the first set of given values. K3, Y2. 180 divided by 6, the product of 3 and 2 is 6. 180 divided by 6 is 30. Is our constant of variation. Substitute 30 here. Z equals 30xy will be our equation of variation. Z equals 30xy. From here, we can now solve for Z. Yung weight. What will be the weight? Substitute x by 5, y by 3. 30 times 5. 150 times 3 is 450. This will be the weight of the wood. So the weight of the rectangular wood is 450 grams when the length is 5 meters and the width is 3 meters. That's an example of a joint variation problem. We have here number 4. This is an example of a combined variation because it involves direct and inverse variation. The number of minutes M needed to solve an exercise set of variation problems varies directly as the number of problems N and inversely as the number of people P working on the solutions. It takes 9 people to 27 minutes to solve. It takes 9 people and 27 minutes to solve 3 problems. How many minutes will it take 15 people to solve 10 problems? First, identify the two sets of given values. For the first set M, number of minutes, 27 minutes. N, number of problems, 3 problems here. And P, number of people, 9 people. So it takes 9 people, 27 minutes to solve 3 problems. Now, how many minutes? Okay, minutes unknown for the second set. For the number of people, 15. For number of problems, 10 problems. Yung M, solve natin dito sa second set. First, let us deal with the first set, solving for the constant of variation. Our equation will be M is equal to Kn over P because M varies directly as N and inversely as P. M equals Kn over P. Now, substitute the value of M by 27, N by 3, P by 9. Then, 3 over 9 is 1/3, diba? So pag 1/3 ito, multiply mo yung 3 by 27, that's 81. Yun yung shortcut. So, yun. 27 equals 1/3 K. Multiply both sides by 3. 27 times 3 is 81. 81 is the constant of variation. Substitute here now. M equals 81N over P is our constant of variation. From here, we can be able to solve the unknown variable in the second set, which is M. 81N over M equals 81N over P. So 81 times 10 divided by 115. 810 divided by 15 is 54. So it will take 54 minutes for 15 people to solve 10 problems. Yun. So that ends our part 1 of our lesson on solving problems involving variation. Thank you very much for listening. See you on part 2 and part 3. Bye.